Hi. The speed of light is constant. It's measured the same on any perspective. But how? Now, it sounds like a fairly simple question to answer, but when you put motion into the mix, a whole new theory was created just to answer this simple question. Let me show you what I mean. Let's say your friend is approaching us at 2 meters per second and I move towards him with the same speed. In your perspective, he is approaching you at 2 meters per second. And for me, he's approaching me at 4 meters per second. But now let's say light is moving towards us and I move towards it. Will the speed of light be different in our perspectives just like the previous scenario? Well, no. The speed of light is constant. It's always measured the same in any perspective, moving or not. So how can we keep it the same relative to any perspective? Of course, by using a treadmill. So the speed of light will always be the same no matter how we move. It sounds silly, but this is essentially what happens when you're in motion, and this treadmill of our universe that keeps the speed of light constant is the stretching of space-time. To visualize it, space-time is the mathematical model that combines your movement through space and time as interconnected dimensions. Now let's say this is our space-time, where every point in the y-axis represents a second and a meter for every point in the x-axis, and this space-time stretches by a factor called the Lorentz factor. Now say you're traveling at 86.6% the speed of light, which will give us a Lorentz factor of 2. This just means that your space-time is stretched by 2 times, changing what you used to measure as 2 seconds to just a second, and 2 meters to just a meter in your moving perspective. Because of this, everything around you will seem like it's in fast forward and compressed. These effects are called time dilation and length contraction. But length only contracts parallel to your motion because when light travels perpendicular to you, it can be constant without needing a treadmill. But you may ask, Oy, how does that translate into the real world? Well, here's a basic example. Let's say light will travel on a walkway that is 1 light second long, and you and your friend are tasked to record 2 things. 1 is how long it takes for light to reach the end, and 2 is how far it traveled. But the difference is, you are stationary and your friend is traveling parallel to it at 86.6% the speed of light with respect to the walkway. And off he goes. In your perspective, you will measure that light reached the end of the walkway in 1 second and it traveled a distance of 1 light second. But for your friend, because his space-time is stretched, he will experience length contraction and time dilation. So for him, light reached the end in just half a second and traveled only a distance of half a light second. Your measurements vary, but in both of your perspectives, the speed of light is measured the same, and that's what matters. Simple everyday things can lead to complex concepts, but understanding these complex concepts can be as simple as doing cardio.